drawing some inspiration from the performative data that Peter talked about, my question will be for you, Fred. If you could talk a little bit about some of the energy and performance, environmental performance issues related to such a big transit center, whether it's the climatic responsiveness with the open air ventilation or dealing with the exhaust of all those buses coming through there. It'd be good to know a little bit more about the performative aspects of the big transit center.
And I'm sorry, I didn't include that in this show. That's a whole other show.
Yeah.
I may do that tomorrow in my Pechacucha, I'm not sure, but essentially, when we started the transit center, we realized that, frankly, that the lead checklist was actually inadequate to do what we're trying to do. It's not that we're trying to reinvent sustainability, but for instance, the lead checklist at least 10 years ago, frankly, it didn't even recognize natural ventilation. It didn't recognize underfloor heating and air conditioning. There were many, many things that we wanted to do, that we needed to do, that were well beyond what the requirements might have specified. Our big objectives when we set out was really simple, and that is to be, for energy usage, to be 40% below ASHRAE. And ASHRAE requirements in California are already really restrictive. So it's 40% below an already very low target. Given current measurements, it looks like we're going to actually be 50% below ASHRAE. That's coming from a couple of areas. First of all, I didn't show it today, but the entire length of the building is one huge geothermal installation. It's probably it could be the biggest in the United States. It's one of the biggest in the world. The geothermal installation has allowed us to, frankly, this is interesting, to remove almost every cooling tower from the project. We have one cooling tower for this huge, huge building. We have one cooling tower left, and that's only an emergency cooling tower. So as a matter of fact, the building's geothermal system is helping to heat and cool the building. It's really acting as the heat exchange that a cooling tower would need to do. So there are just literally dozens of things like that. The park has a whole stormwater management system. We're able to conserve some amazing number, like 13 million gallons of water each year after phase 2 is built. So water, energy management, storm runoff, simple issues were absolutely central to what we were trying to do. Now, I will say what was fascinating about the whole effort is that these issues kind of grew organically. You know, you begin with a big idea, and you know, a big idea like a park, like a 5-acre park on the roof of a building. Then you start finding everything that you can make of that 5-acre park. It's not an inexpensive idea, admittedly, but if we could find ways, you know, the ASHRAE standard is a good example. If we could find ways for that park to help in other ways, perhaps it will never pay for itself, but perhaps it could help put a fairly sizable contribution toward its own cost. So the whole building is one kind of big organic sustainability example. And that's why I was really interested in Christian and Peter's presentations, because I realized that you know, escalators and elevators are part of public transit. If we can start thinking about a building like this, which is all about movement, it's all about people coursing through during their day, but think about it as one very big organism with every piece interlinked somehow through digital information, through just the placement and design of things. These can become really extraordinary buildings. And they don't have to necessarily be extraordinarily expensive buildings. They can be buildings that make so much sense at so many different levels that the economics will be a kind of a natural result of what you're trying to achieve.
I'll posit one to Peter. A little overwhelming, all the big data you talked about, and all these buildings that are talking to each other and have a lot to tell us. I was curious about what kind of information you might get that pertains to resiliency. And when I say resiliency, I'm thinking about whether it's extreme weather conditions, climate change, what type of big data you're gathering that can address longer-term macro resiliency issues.
Yeah, I think it's a good point. And actually, it was interesting that Christian addressed it too, was that, you know, there's so much data becoming available out of our buildings, but you've got to utilize a platform and utilize partners that can help you provide the analytics behind it. So can one technology or one company do it all? No. I think you need to embrace partners and other software packages to help crunch the data and come out and find anomalies and find out where and build your resiliency for your buildings too. So yeah, I think it's a combination of bringing the data in from the building, also bringing weather data in and historical data from weather patterns and applying it that way. But yeah, build up an ecosystem of partners is the way Siemens is doing it also, and Schindler.
Another one for Christian. You know, Christian, talking about using of lifts, there's all this data that you're gathering, yet there's always still the problem of the human factor. To use an example, you know, where, because here in Asia, in Hong Kong and China, where I work a lot, very heavy users of lifts, much higher density of occupation of people on floor plates than we have in North America. And, you know, at lunchtime, 8 people leave to go out to lunch together, but only one of them has pushed ground floor on the destination demand. And so then the whole thing goes out of whack because of the human factor. Just some comments about how you deal with the stupidity of humans trying to interact with your very smart machine.
Yeah, you cannot avoid that, I believe. But you know, it's all about learning and seeing the pattern behind. So if you collect all the data, if you not only, let's say, collect the calls, but also see, let's say, the weight measurement of the elevator or of the car, and if you combine this information, and then it's all about learning, identifying similar patterns, similar situations, and take the right conclusion out of it. But you're fully right, and the behavior of people in transit management is different from country to country. And you have to take that into respect, and you have to learn the different patterns country by country, and there's no algorithm, there's no, let's say, machine learning which fits for the whole world.
Mm-hmm. How many floors in the Salesforce tower is Salesforce actually taking?
It's a 63-story tower. Mark, how many floors are they taking? It's 2/3, I believe.
And so, not to be anti-lift and escalator, but when you have a big corporation
Right.
like that spread out over a tower, in terms of encouraging a healthier lifestyle and getting people to use interfloor stairs more often, is there any initiatives or design that helps encourage people moving between floors using their legs instead of these very smart lifts?
Absolutely. It's actually, it looks like a solid tube, but it's actually an eroded tube. There are several significant atria throughout Salesforce's areas. So Salesforce is very, very aware of that. They also are very aware of how much time people spend in elevators. Don't take that the wrong way. But the idea would be to, you know, there's a disruption of human communication caused by vertical movement in buildings, as we all know. And if you're in a corporation who prides itself on the interaction and the accessibility to information and to each other, elevators actually work against that. It's one of the arguments for a horizontal corporate campus. But what's happening in the Bay Area right now is that whole paradigm, of which there are many, many big examples, big expensive examples out in the suburbs, are really now being questioned as to their social and cultural impact. And that's why you're now starting to see, I mean, even Facebook is moving a big piece of its operation back into near the transit center. So people who live and work in those places they would like to walk to work, and they'd like to walk from their colleague's office to the other and not a mile away. So that trend is happening very, very rapidly. I think it's very much a part of the future. But the Salesforce way of using space is really quite remarkable. Full of atria, full of kind of eroded spaces. And it looks quite exciting.
Well, I have to come in with the devil's advocate question as we talk about the Internet of Things and the smart buildings and what have you. But I would actually throw this open to all three speakers. Is there a way that we can anticipate or design out the potential for all of these wonderful smart buildings to be hacked? It seems like every day, we see another disclosure of some electronic entity that has been hacked. So it's not difficult to picture the nightmare scenarios of buildings kind of going HAL 2001 on us. What kind of protocols are in place to act against that happening?
From the beginning, from the design phase, all the way to implementation, and all the way through to further development, the whole cybersecurity topic is addressed stringently. Is there one way to do it? No, there's many processes reiterated through the whole design phase and implementation phase that we go through. But yeah, you just got to be on top of it, and it's evolving quickly.
And this is one of the reasons why we have teamed up with leading industry partners, which, let's say, have the power, the capability, the network to act on a very high level of cybersecurity, which a single company, even with 60,000 employees worldwide, might not be able to do. So we are coming back to having the right network of partners to deliver a platform which can guarantee a certain level of cybersecurity.